Hello and welcome back. This last example of the section, example 8.3.2, was inspired by my daughter who's obsessed with space. So in 2145, 10,000 people colonized an inhabitable planet called Tau Ceti. In 2215, the human population of Tau Ceti had jumped to 50,000 people. Assume that the population on Tau Ceti has exponential growth. When would Tau Ceti have 8 billion people? So when would it have the number of people that we have today on Earth? All right, so we're asked to find the number of people. So let's take A of t to be the number of people on Tau Ceti. We could do in year t, but what I like is to start at year 0 at 2145. I find that's easier. So let's say t years after 2145. And we're told that it's an exponential growth, so PERT. All right, so what are we given? We're given that P at year 2145, that's t equals 0. So, A of 0 is equal to 10,000. And we're given that let's see, so that's 2215 minus 2145, that's 70. So A of 70 is 50,000. All right, so 10,000 is PER times 0. It's just P. So that really helps us get started. So that's part of the reason I wanted T after year 2145. That makes finding P super easy. And then all you have to do is figure out R, and that's going to depend on this. So after 70 years, we're at 50,000. That's P, which is 10,000, e to the R times 70. All right, so if I divide by 10,000, I get that 5 is ER to the 70. Then I'm going to apply log to both sides. E and log are inverse functions, so they cancel. And I'll get that R is ln of 5 over 70. All right, so we found P and we found R. So what we actually showed was that A of t was 10,000 e to the R. Actually, let me put it here. E to the R, so ln of 5 divided by 70 times t. We need to figure out, if we look back at what the question was asking, when would Tau Ceti have 8 billion people? So we want to know when A of t would be equal to 8 billion. So that's 8 million, 3 more 0. All right, so that's 10,000 e ln of 5 over 70 t, and we're looking for t. So I'm going to divide by 10,000. I'm going to get 1, 2, 3, 4, 0 fewer. So I have 1, 2, 3, 4, 5. I'm getting rid of 4 zeros. And so I'm left with this. That's 800,000. Again, I'm going to apply log on both sides. Log of 800,000 is ln of 5 over 70t. Again, log is going to cancel with the exponential, and I'll get the exponent out of it. So I can solve for t now. T is log of 870 over log of 5. I plug that into the calculator and I got 591 years and some. All right, so that's interesting, but it's not really answering the question. So when I need to give a year, so I'm going to take, let me do it here. So I'm going to take 2,145, add 591 plus a bit. So I'm going to get something plus a bit, 63172. So in the year, at some point in the year, 2,736. Um, the Let me erase this just to finish my sentence. The population of Tau Ceti will um, reach 8 billion. That's the answer. All right, so not so bad. I just had to start by finding a formula for A of t, and then I just have to solve for t. You often have to apply log. We had to apply log here and apply log here. That's really because if I apply log to e to the y, I get y. And so every time you want to solve for something in the exponent, you apply log to both sides and the exponent comes down.